Hello everyone, welcome to the second part of tutorial 10. In the first part, we downloaded the 14 parts from Blackboard and we made the assembly as seen in this photo. So we assembled the part together and we fixed the home view. That means when I check the isometric view, I will get the same view available in the question. Now, today we'll continue by checking interference. So, what do we mean by checking interference? Let me just do that check. If I evaluate an interference detection for the whole assembly and calculate, it tells me that I have one single interference of a volume of 0.01 centimeter cube, and in details it's between the sew pulley and the holder. So if I check this, I can see that the assembly actually has some interference. That means two parts shares the same area, which is not realistic in the actual life. So if I buy this mechanism in the future and I'll try to connect the holder to the pulley system, they will not, because they cannot share the same area. So interference detection means that you want to check your design for such interferences and you want to avoid them. So simply now I can see that I have some problem and I did not recognize that while doing the design. So what I can do now is simply making my design perfect through checking this holder and find its mates and find the mate I created between surface 1 and 2, which is this one. So in order to avoid the interference, I can remove this mate, so edit, or simply I can say shift this holder to the left a distance of maybe 1 centimeter. So you can see that the holder is away from the pulley, and I'll say confirm. Or maybe I can say go to the holder and reduce its size. So I don't like this additional surface, so I can go to the holder itself and cut out some material so that this surface, it will touch this plate. So for now, I don't care about the details of the drawing because it is only a practice problem. But as a designer, you have to fix or modify your design based on the need of the application. Okay. Now, after we fix that interference, let's go again, evaluate interference detection, and let's calculate. Now it says no interferences. That means this design is perfect in terms of interferences between parts, and I can confirm, and simply that is the interference detection. If I go again to the home view, I will find the perfect design. Good. Always when you finish a design, you have to check for interference to avoid problems after manufacturing the part. So initially the CAD is computer-aided design. You want to design the components without any fault or problem. So it's better to check from the initial design. Okay. Now we want to create the exploded view. As you know, the same assembly can be viewed as exploded components to show the users how the components are assembled together or how they are mounted on each other. So how to create this exploded view? If I go to the assembly, and I can see that I have one assembly with components or parts and mates, a lot of mates, but now I'm not changing anything on the assembly itself. So I will go to Assembly tab and find Exploded View, and I will get something new tab for Explode Components. So basically in the Exploded View, I have to show the user how I'm going to mount the components on each other. I can say that start by removing this nut and the saw itself in x-axis. As you see, that's x, y, and z. So if this is the isometric view, I selected two components, nut and the saw itself, and I want to move them. It says in z-axis, but I want to select x-axis, so you can see it's x, and I want to move them a distance of 1 centimeter, and that's very short. Let me say 20 centimeters, for example, and add a step. So you can see that I moved them together 20 centimeters from their original location. If I go back again to the isometric view, you can see that the saw and the nut will go together as one single step. Can I edit this? Of course I can edit, and I can delete if I want. So what I want is I have to remove the saw, delete, and I want to make them in two different steps. So step number 1 will be only 20 centimeters for the nut, done. And I want to add a new step, step number 2, to take the saw only in x-axis a distance of 15, and add a step. So I did remove the saw 15 centimeters, but in positive x-axis, and I wanted to move the saw in the negative x-axis. So again I can edit step number 2 and change the direction and confirm. So this is only an exploded view for two components. If I say collapse the components, they will go back to their original shape, so I'm not changing the original assembly. And if I right click and I say explode, it will show me the exploded view. If I say animate collapse, it will show me an animation for the collapse. So it's the saw first and then the nut. If I say animate explode, it will show me animation of how the parts are exploded. Okay, then I have to close this animation. If I want to add more steps, I can right click and edit feature, and that's only step number 1 for the nut, step number 2 for the saw. Maybe I can add the cover in x-axis, negative, a distance of 10, and add step. Okay, maybe I can remove the motor in y-axis this time, positive y-axis, a distance of 20, and then add step. So I don't like the motor to go without the pulley, so let me edit step number 4, and with the motor I will check the pulley system, so they will go together, and I like this, and it's done, and so on. In step number 5 I can say the small shaft, bearing number 1, bearing number 2, and the pulley system plus the holder plus the blade can go in z-axis, negative z-axis, a distance of 20, and then I have to add a step. And there is no need to remove those two components, because now everything is very clear and I know how the components are connected. So if I confirm this, I will have an exploded view of 5 steps, and if I collapse, then I'll go to the original assembly, so click collapse, they will go back. If I right click and explode, I will get this. If I right click and animate collapse, I will get the animation for the collapse. Or close the animation and right click and animate the explode. So they go one by one, step by step, 5 steps. Okay, and that's it. Now, how to go back to the original assembly? Let me finally collapse. Then this icon, configuration manager, shows the exploded view, and this tab, feature manager, it will show me the assembly. So I'm not having two different assemblies. The same original assembly has the exploded view in this configuration manager. Okay, and if I save this assembly now, I have the two views, the original assembly plus the exploded view. Okay, so this is the part related to exploded view. Now, what about video animation? Now, video animation, we know that this mechanism will go up and down while the shaft is rotating. So how to create such kind of motions? I want to make something like this. So this video shows the exploded view animation plus how the mechanism will work. So that's the animation of the exploded view, and then the collapse animation, and then how the mechanism will rotate the saw and how it can go down to cut specific material. Okay, good. How to develop this animation? Now, if you go down, you can see that we are in the modeling tab. This is only a model, and I can go for motion study. So in the motion study, I have the time axis from 0 to infinity. I can record videos or animations forever. I have the same assembly page in the home view, and I have many icons. One of them is the animation wizard. So if I click the animation wizard, it shows me how to rotate a model, how to explode a model, and how to collapse a model. Usually there is no point of rotating the model unless if you want to show some hidden details in the other side. In this case, you have to rotate the model. Explode is good and collapse is also good. So what I can do is I will start with exploding the drawing. Next, the duration of the animation for exploded view will be 5 seconds starting from 0 second and finish. So it's now recorded from time 0 to time 5. I have animation for exploded view. If I click again the animation wizard, I will say collapse. Next, duration is 5 seconds, but I have to start at 5 after the exploded view and then finish. So total video now is 10 seconds. Now, how to make a motor to show the rotation of the saw itself? Now, if I go and select motor, select component, this is the saw itself. It will rotate in this direction with a constant speed of maybe 20 RPM, and then confirm. So this is motor number 1. Okay, and I can take its time to start from 10 to 15 so that it will not start at the same time with the exploded view animation. Okay, now if I calculate this motion, calculates the motion study, run, so it will try to understand how the movements will go, exploded and then collapsed, and then finally the motor will rotate, which is very good now. So if I want to save this animation, I can go to save animation, and it will go to the same folder, tutorial 10, and I can change the name to cell mechanism, for example, the aspect ratio and everything, save and OK. Good. So it will recalculate the movement, which is exploded and then collapsed and then animation, and automatically it will be saved in the folder. So now it's doing the calculation, and that's it. So if I go to tutorial 10 folder, I'll find that the cell mechanism video is created, and it will have the exploded view and the collapse animation and the animation of the cell. Okay, good. So now let's go to the third part, which is how to create 2D drawings. Now, if you think of this mechanism as a product, I did the design, making the parts, I made the assembly, I created the exploded view and the animation. So I want to send this design to the manufacturing people, so I have to give them details, like what are the dimensions of each component. So for samples, if we take part number 3 and part number 6, so part number 3 is the sew path. Let's go. Of course, I can cancel the motion study by going to the model itself. So this file now, if I save, it has the main component for the assembly, it has the exploded view, and it has the motion study. So it will be together in the same file. Going back to the model, and I can cancel this, save all. Now, if I open part number 3, which is the sew path, open, I want to create a 2D drawing for this element to show the exact dimensions. Now, if the part is open already, I can go to New and make drawing from this part. So automatically a 2D drawing page will be open, and I have to select the size. It's A4 or A3 depending on the dimensions. So I think A3 will be suitable for this dimension, and OK. Now in this page I can see the whole possible views for this part. So I can say show me the front plane. If I drag this, I'll get the front plane, the bottom plane, the top, right and left, and escape. If I check the view palette, I can also select the isometric view or current view, so I can drag it. Now, in order to differentiate between 2D views and 3D views, I can select this view and show the object shaded with edge. So this will be my isometric view, and those are the 2D views. Now, there is no point of repeating right and left views because they are similar. So I can delete one of them. Same thing. There is no point of having top and bottom unless if I have some details. So this hole, it's very obvious that it's in this side. So this is unnecessary. Delete. And same thing. The width of this part can be found in this length. So I don't need this view as well. So these two views can show me the exact details or dimensions. Now, can I put the dimensions? Yes, of course. I can go to annotation, smart dimension, and show part number 1, it's 6 centimeters, part length number 2 is 13, the height of this shaft is 2.5, the diameter of the bin is 1 centimeter, and so on. The distance between this edge and this edge is 0.8, and so on. The thickness of the part is 1.4. So I have to give the important dimensions for the manufacturing team in order to understand the part and make the manufacturing process. Now, can I give the dimensions automatically without giving the details manually? Yes, we can. So let me close this part and I will make a new part, because in the tutorial we have part number 3 and part number 6, the plate. Good. Now, I don't have the plate open in SolidWorks. I have it already, that's the part of the plate, but I want to open SolidWorks, new, and then drawing. I have to select maybe an A4 size paper, and then I have to browse the component that I want to make. Browse, plate, open. Now I can give the exact view I have in the mouse, or escape. I can go to view palette. Now I don't have any option, so I have to refresh, but before that I have to select the element, which is plate, and refresh. So I have all the components, and one of them is the isometric view, so I can drag it and I can show the view, the 3D view of the part. Check the view and make it with edges. Now I can provide the dimensions manually by going to smart dimension and check A and B and so on. Now there is an option. If I go to annotation, smart dimension, and instead of developing the dimensions manually, I can go to auto dimension, and then I select one view and I confirm. So it will provide all detailed dimensions used in making the parts. But the issue is, for complicated parts, or like this part, it has many dimensions, because each center, for example, it needs the radius of the circle, the X components and Y components, and I have 4 holes, and I have 16 holes, and I have different parameters. So in this case, auto dimension will not work. But for simple drawings, I can easily use auto dimension, and I can delete any one of them based on what I need to show to the manufacturing team. Okay, so this is how to create 2D drawings. Of course, I can save this file as a PDF file. So that's the plate, drawing, and PDF, and the same folder, tutorial 10, it's plate, and then save. So if I go to tutorial 10, that's the plate, and this is the 2D drawing of the plate. Okay, good. Now, what if I want to create a 2D drawing, but not for a single part, for the assembly itself? Now assume that I have this assembly and I want to create a drawing from the assembly itself in an A3 size paper, and I have all the views available to me. So I would select the right view, for example, the front view, and that's it. Escape. So in this drawing, I will only develop a smart dimension for the main height and length of the mechanism. So the height will be something like this. It says 25 centimeters. What about the length? It is something like 28 millimeters. So I'm dealing with a mechanism or a system that's very small, less than 30 centimeter by 30 centimeter. What about the other width? So if I measure, for example, from this point to that point, total 25.99. So sometimes I need to show this in the drawing file in order to provide a rough estimation of the dimensions of the system. Good. I can also place the explored view in the drawing. I can check the view and make it with edges, 3D view. I can, by the way, scale. So this view, change the scale. Instead of auto scale, I can use custom scale. So maybe 1 to 2. So I can just place the component inside the paper and confirm. Now, how to show the balloons, the numbers available in the tutorial with the bill of material, the table components and names. If I go to annotation, auto balloon, and I select this box, this view, it will create a list of components, and I only need to organize the arrows. So that's indication of part number 9, and that's part number 6, and that's part number 14. Sorry. And that's part number 7, which is the motor. Part number 8, the pulley system. And I can control the head of the arrow. I can take it to the other side. And this is the cover. 11. And that's 13. The nut. That's 12. The saw. And so on. So the quality of the explored view we did earlier will determine the quality of the balloons and how I can give the annotations in proper places, and then we have to work on that until we get something useful to the users to understand how the components are mounted. For example, 1 and 2, they don't explain exactly because both of them they point to the same part. So we have to check and say this is number 1, which is the base. Then I can select different point for the base, which is maybe something like this. And that's number 2, which is the rotating plate, and so on. Now finally, can I make that table? So if I go to tables, bill of materials, for this view, and confirm. So I get the table attached to the mouth, and then I can place it somewhere here. So it shows the numbers as listed in the balloons. It shows the part name. I can write a description. I can say that this part is the base part and it's made of steel, for example, and so on. Now we're done with tutorial 10 and we have finished almost everything. So try to practice this tutorial, and thank you for watching the video.